So we already know how to solve the following problem. It's just a linear equation here. And so I want you to go ahead and solve for x and make sure you show every step of your work. Now we're going to arrange all of these steps into a two-column proof to prove that the solution is x equals 11 over 4 and justify what we did in each step of the work. Okay, so here's your two-column proof. So sample proof 1, the problem will contain at least one given statement, and your result must be the statement you are asked to prove. So we are given this, and we are asked to prove that x equals 11 over 4. So then we have our two-column proof, and here we go here. So the first column contains a series of statements that leads us logically from the given statement to the facts we are proving. And then on the right side, the second column contains the justifications. That's where you put your postulates and theorems and properties. So on the first line, we always start with what we are given. So we are given this equation here, and that is what we're given. And so we just write given there, okay? And then you see that although I did not write what we subtracted from each side, we have the resulting step. So we subtracted x from both sides, and then this is what it results in. And that, of course, is the subtraction property of equality because we subtracted x from both sides. Then they added 8 to both sides. That would be the addition property of equality. And then they divided both sides by 4, and that would be the division property of equality. And then you'll notice our statement up here, it says x equals 11 over 4, and we have 11 over 4 equals x. So then we would need to reverse it and say x equals 11 over 4. In our final statement, it needs to match exactly what you want to prove, and that is the symmetric property of equality. So very basic two-column proof there. You actually did this last year in Algebra 1, and so we're just practicing it today. Okay. Sample proof number 2. Here, we're given angle ABC is congruent to angle DEF, and angle DEF is congruent to angle JKL, and we want to prove that angle ABC is congruent to angle JKL. And you might already be thinking, okay, I kind of know how to do that right now. But the first statement should always be copied exactly onto line 1, and if there are multiple given statements, additional statements will have their own line. This does not always follow, but for this class, we're going to go ahead and do that. And so not every single, you'll see some of these might be together on one line here, and that's really okay. So the justification for both statements were simply given. So we would assume that they're true since they gave us that statement, okay? So we were given these two things, and then we can say this, quite honestly, it's a very simple proof because of the transitive property of congruence. And 1 and 2, the reason that we specify that, since substitution and the transitive property are always used to combine two previous statements, they want to specify which lines you're using. So we're using information from lines 1 and 2 to make a new statement because we're combining these two. Okay. You do not, of course, need all of that space there, so you would just leave it blank. Okay. So let's go ahead and complete this proof together. So we're going to need to use the properties of equality to solve the equation, and then we may need to use the transitive property. So go ahead and see if you can fill in this proof here. Pause the video, and then when you're ready, go ahead and hit play. Okay, so here we have our given statements. X divided by 10 equals 3, and y minus 5 equals 25. Multiplication property of equality says that x equals 30. Addition property of equality says that y equals 30, and therefore we can say the transitive property of 3 and 4, since x equals 30 and y equals 30, x equals y, and that's a transitive property combining statements 3 and 4. Okay, we're trying to complete this proof here. So go ahead and pause the video again, and see if you can come up with that proof. All right, so here we go. We are given those three statements, so those are the first three lines. Then they use n equals t. That's a transitive property that we are combining 1 and 3. And then they use the substitution property to combine 2 and 4, because what they're doing is they are replacing the t with an n using substitution property of equality there. And then they're using the subtraction property of equality. They're subtracting n from both sides to get p equals n. And then they're using the transitive property, combining 4 and 6. So if n equals t and p equals n, then you can say t equals p or p equals t. And that's our proof right there.